Let's now move on from hashing to encryption. Now, while a hash function can be used to prove the integrity of data, it cannot be used to store or transmit that data. Now, an encryption algorithm is simply a type of cryptographic process that encodes data so that it can be recovered or decrypted. Now, the use of a key with the encryption cipher ensures that decryption can only be performed by authorized persons. Now, speaking of encryption ciphers, there's two of them. You've got the simple substitution cipher, and then you've got the transposition cipher. Now, in a substitution cipher, the units will be replaced in the plain text with different types of cipher text. As an example, let's say ROT13. This simply means rotating each letter 13 places so that A becomes N. So if you take any letter, simply move forward in the English alphabet by 13 places and you get the actual value. So in this case right now, the ciphertext URYYBJBEYQ would simply mean hello world. You can try that out. And then in a transposition cipher, the plain text will stay the same as the ciphertext, but their order is changed according to some sort of mechanism. So if you were to consider the ciphertext HLOOLELWRD, if you were to write them out in columns and rows and then concatenate them, you will get the actual message. So looking at the ciphertext, if you were to start from H and then you go down to E, you go back to the second column where you have L, you come down again to L, you go to the third column, O, and so on, you will get the words hello world. That's how that would work. Now, symmetric encryption. There's two main types of encryption, remember, symmetric and asymmetric. So in symmetric, here, both encryption and decryption are performed by using the exact same secret key, and it can be used for confidentiality. And there is two types of symmetric encryption, the stream ciphers and block ciphers. We'll talk about them a bit later. But here's an example of how symmetric encryption would work. So Alice and Bob, they will have access to the exact same symmetric key. Alice will take the key and will encrypt the file using that particular symmetric key. The file becomes a ciphertext. She sends the ciphertext to Bob. Bob then uses the exact same secret key to decrypt the ciphertext and get the actual message that Alice sent. Now, symmetric encryption, it's also referred to as the single key or private key or shared secret encryption. It is extremely fast because it's a single key that's been used. You can use it for bulk encryption. However, it can be very, very vulnerable because since it's a single key, if that key is stolen, then the entire encryption algorithm will fall into pieces. Now, it cannot be used for authentication or integrity because both Alice and Bob have access to the exact same key. So, remember with symmetric encryption, you've got two types, stream ciphers and block ciphers. In a stream cipher, each byte or bit of data is encrypted one at a time. So here the plain text is combined with a separate randomly generated message calculated from the key and also an initialization vector IV. Block ciphers. The plain text is divided into equal size blocks, usually about 128-bit. Now, in a scenario where there isn't enough data in that plain text to divide it completely into equal size blocks, that plain text will be padded to the correct size. So as an example, let's say you've got 1200-bit plain text. In order to make it very easy so that the plain text is divided equally to 10 by 128-bit blocks, 80 bits would be added to the plain text to make it 1280 in length. That's what's known as padding. Now, the advanced encryption standard, the AES, is the default symmetric encryption cipher for most products. It's usually either 128 or 256 bits. Now, there is this thing you need to be aware of known as the key length. The range of key values available to use with a particular cipher is called the key space, and it's typically equal to 2 to the power of the size of the key. Naturally, the longer the key, the more powerful the encryption. Let's move on to asymmetric encryption. Now here, both encryption and decryption are performed by two different both related public and private keys in a key pair. So each key is capable of reversing the operation of its pair, and they are linked in such a way as to make it impossible to derive one from the other. Now here's an example. So Alice here, first of all, Bob will generate an asymmetric key pair and will keep the private key secret. Bob will then publish the public key readily available, and Alice will be able to keep a copy of that key. Alice will then encrypt her message using Bob's public key. That file becomes a ciphertext. She's going to send it over to Bob. Bob will then use his own private key to be able to decrypt that ciphertext into the actual message. And then possibly if Mallory comes in, try to sniff the network, and learns the public key value and ciphertext, she can try to inject some sort of a malicious file into that document, but Mallory cannot use Bob's public key to reverse the encryption because she doesn't have access to Bob's private key. That's exactly how it would work. Now in asymmetric encryption, you can use this to prove the identity as the holder of the private key cannot be impersonated by anyone else. So you can use it for integrity and even authentication. The major drawback of this encryption is that it involves substantial computing resources because you're using two keys now. So you can't really use it for bulk encryption, and it's really not that fast. It's mostly used for authentication and non-repudiation and for key agreement and exchange. Now, please keep in mind that asymmetric encryption is also very commonly referred to as public key cryptography algorithm. So it's also known as the PKI, PKC, and so on. And the products are typically based on the RSA algorithm. Now, RSA is the Ron Rivest, Adi Shamir, and Leonard Edelman. They published the RSA cipher back in the year 1977. The RSA algorithm provides the mathematical properties for deriving key pairs and performing the encryption and decryption operations. This particular type of algorithm is also what we call a trapdoor function, and that's because it is very, very easy to perform using the public key, but it's difficult to reverse without knowing the private key. You also have something known as the elliptic curve cryptography, not quite as common, but it's also another type of trapdoor function. The advantage of the ECC, the elliptic curve cryptography, over the RSA is that there are no known shortcuts to cracking the cipher or the math that underpins it regardless of key length. That's it for encryption. Thank you for watching. I will see you in the next class.